The National Electrical Code, or NEC, requires a disconnecting means for all motors over 1 horsepower. This disconnecting means must be within sight of the motor and readily accessible. The purpose of a disconnect serves several key purposes. Firstly, safety. It isolates the machine from power when not in use, preventing accidental startup. Secondly, maintenance. It allows for safe servicing and repairs without exposing workers to live electrical components. Thirdly, emergency. It provides a quick way to cut power to the machine in case of an emergency. An on or off switch on a machine may not meet the NEC requirement for disconnecting means because it might not be readily accessible when the machine is in use. For example, it might be located on top of a terminal block, which may be difficult to reach. Therefore, a second disconnect is required before the machine, especially if the machine is not within sight of the panel. This disconnect can be a circuit breaker or a fuse disconnect switch. A breaker lockout is not sufficient as a disconnect because it does not isolate the machine from all power sources. It only prevents the breaker from being turned on, but it does not disconnect the wires from the machine. The solution is to install a circuit breaker or fuse disconnect switch before the machine, within easy reach and in sight of the on or off switch. This will provide a readily accessible disconnect that meets the NEC requirement and ensures the safety of workers. The NEC mandates a disconnecting means for motors exceeding 1 horsepower to ensure safety during maintenance, prevent accidental startups, and enable emergency shutdowns. This disconnect must be readily accessible and within sight of the motor. A machine's on or off switch might not fulfill this requirement if it's not easily accessible during operation. In such cases, an additional disconnect, such as a circuit breaker or fuse disconnect switch, is necessary, especially if the motor isn't visible from the electrical panel. A breaker lockout, while preventing the breaker from being turned on, doesn't completely isolate the machine from power. Installing a readily accessible circuit breaker or fuse disconnect switch before the machine ensures compliance with NEC regulations and enhances worker safety. For a 225 amp 3-phase machine operating at 240 volts, situated 140 feet from the panel, the NEC mandates a readily accessible disconnect switch. The existing on or off switch on the machine might not meet this requirement due to accessibility issues. A breaker lockout isn't sufficient as it doesn't fully isolate the machine from power. The solution involves installing a suitable circuit breaker or fuse disconnect switch before the machine to ensure both compliance and safety. Let's delve deeper into the NEC requirements for motor disconnects. The primary reason for these requirements is to ensure the safety of personnel working on or near electrical equipment. Firstly, the NEC mandates a disconnecting means for motors greater than 1 horsepower, emphasizing accessibility and proximity to the motor. Secondly, the purpose of this disconnect is threefold: to prevent accidental startups during maintenance, to allow for safe servicing and repairs, and to provide a means of quickly cutting power in emergencies. Thirdly, a typical on or off switch located on the machine itself may not suffice as a disconnecting means if it is not readily accessible or within sight of the motor. Fourthly, in situations where the motor is not within sight of the electrical panel, an additional disconnect is mandatory. This can take the form of a circuit breaker or a fuse disconnect switch. Fifthly, a breaker lockout device, while useful, does not meet the NEC requirements for a disconnecting means because it does not physically isolate the motor from the power source. Sixthly, the correct solution involves installing a readily accessible circuit breaker or fuse disconnect switch in close proximity to the motor. This ensures that workers can quickly and safely de-energize the equipment before performing any maintenance or repairs. The NEC emphasis on readily accessible disconnects stems from the need to minimize response time in emergency situations. If a machine malfunctions or poses a hazard, workers must be able to quickly shut off the power supply to prevent injuries or further damage. A disconnect that is located in an obscure location or requires special tools to operate is not considered readily accessible. The requirement for a disconnect to be within sight of the motor is also crucial for safety. This ensures that the person operating the disconnect can visually verify that the motor has stopped running before beginning any work. It also prevents someone from inadvertently turning the power back on while someone else is working on the equipment. While a breaker lockout device can prevent the circuit breaker from being accidentally turned on, it does not provide the same level of safety as a dedicated disconnect switch. A breaker lockout only addresses the possibility of someone inadvertently energizing the circuit from the panel. It does not protect against other potential hazards, such as short circuits or ground faults within the machine itself. A proper disconnect switch, on the other hand, physically isolates the motor from the power source, eliminating the risk of electrical shock or arc flash. In the case of a 225 amp three-phase machine operating at 240 volts, the NEC would require a disconnect switch with a rating of at least 225 amps. The specific type of disconnect switch, whether it is a circuit breaker or a fuse disconnect switch, would depend on the specific application and the requirements of the local electrical code. It is important to consult with a qualified electrician to ensure that the correct type of disconnect switch is selected and installed in accordance with all applicable codes and regulations. The distance of 140 feet from the panel to the machine is also a factor to consider. The longer the distance, the greater the voltage drop in the conductors supplying power to the motor. This voltage drop can affect the performance of the motor and can also cause the disconnect switch to overheat. To minimize voltage drop, it may be necessary to increase the size of the conductors supplying power to the motor. Again, a qualified electrician can perform the necessary calculations to determine the appropriate conductor size. In addition to the NEC requirements, there may be other applicable safety standards or regulations that must be followed. For example, the Occupational Safety and Health Administration (OSHA) has specific requirements for lockout/tagout procedures to ensure that equipment is properly de-energized before any maintenance or repairs are performed. It is important to be familiar with all applicable safety standards and regulations and to follow them diligently to prevent accidents and injuries. In summary, the NEC requires a readily accessible and within-sight disconnecting means for motors greater than 1 horsepower. This disconnect must physically isolate the motor from the power source and must be properly rated for the specific application. A breaker lockout device is not sufficient as a disconnecting means. It is important to consult with a qualified electrician to ensure that the correct type of disconnect switch is selected and installed in accordance with all applicable codes and regulations. Always follow all applicable safety standards and regulations to prevent accidents and injuries. Let us elaborate further on the NEC requirements concerning motor disconnects, emphasizing the importance of safety and code compliance. Firstly, the NEC, as the cornerstone of electrical safety in the United States, dictates the installation of a disconnecting means for motors exceeding 1 horsepower. This requirement is not merely a suggestion but a mandatory safety measure aimed at protecting personnel and equipment. Secondly, the primary function of this disconnecting means is to provide a readily accessible and reliable method for de-energizing the motor circuit. This allows for safe maintenance, repairs, and emergency shutdowns, minimizing the risk of electrical shock or arc flash. Thirdly, the NEC specifies that the disconnecting means must be located within sight of the motor and readily accessible. This proximity ensures that workers can quickly and easily disconnect power to the motor before commencing any work on or near the equipment. Fourthly, the concept of readily accessible implies that the disconnecting means should be easily reachable and operable without the need for tools or excessive effort. It should not be obstructed by obstacles or located in a remote or difficult to access area. Fifthly, in situations where the motor is not within sight of the electrical panel, an additional disconnecting means is required at the motor location. This redundancy ensures that workers have a local means of de-energizing the motor circuit, regardless of their proximity to the panel. Sixthly, while circuit breakers can serve as a disconnecting means, they must be readily accessible and clearly labeled to indicate their function. Additionally, a breaker lockout device, while useful for preventing accidental re-energization, does not satisfy the NEC requirement for a disconnecting means. Seventhly, the NEC also addresses the selection and sizing of disconnecting means. The disconnecting means must have an amperage rating equal to or greater than the motor's full load current rating. This ensures that the disconnecting means can safely interrupt the motor's current under normal and overload conditions. Eighthly, the NEC mandates the use of specific types of disconnecting means depending on the application and voltage level. For example, fused disconnect switches are commonly used in industrial settings where high fault currents are present. Ninthly, the installation of motor disconnects must comply with all applicable NEC requirements, including grounding, bonding, and wiring methods. Proper installation is essential to ensure the safe and reliable operation of the disconnecting means. Tenthly, regular inspection and maintenance of motor disconnects are crucial to ensure their continued functionality. Disconnects should be inspected for signs of damage, corrosion, or overheating. Defective disconnects should be replaced immediately. In conclusion, adhering to the NEC requirements for motor disconnects is paramount for electrical safety. By providing readily accessible and reliable means of de-energizing motor circuits, these requirements minimize the risk of electrical hazards and protect workers from injury. It is essential for electrical contractors, engineers, and maintenance personnel to be thoroughly familiar with the NEC and to ensure that all motor disconnect installations comply with its provisions. Let's further discuss the practical implications of these NEC requirements in a real-world scenario. Imagine a large manufacturing facility with numerous motors powering various machines and equipment. Each of these motors, if exceeding 1 horsepower, must have a disconnecting means that meets the NEC criteria. Firstly, consider a motor located in a remote corner of the facility, far from the main electrical panel. In this case, a local disconnecting means is essential to comply with the NEC. This disconnect could be a fused disconnect switch mounted on the machine itself or a circuit breaker enclosed in a nearby panel. Secondly, suppose a motor is driving a critical piece of equipment that requires frequent maintenance. The disconnecting means for this motor must be readily accessible to maintenance personnel. It should be located in a well-lit area and clearly labeled to avoid confusion. Thirdly, imagine a situation where a motor malfunctions and starts emitting smoke. In this emergency scenario, a readily accessible disconnecting means is crucial to quickly de-energize the motor and prevent further damage or injury. Fourthly, consider a motor that is controlled by an automated system. Even in this case, a disconnecting means is still required for maintenance and emergency purposes. The disconnecting means should be independent of the automated system to ensure that it can be operated manually if needed. Fifthly, imagine a situation where a contractor is hired to perform electrical work on a motor circuit. The contractor must verify that the disconnecting means is properly installed and functioning before commencing any work. This includes checking the amperage rating of the disconnect, inspecting for any signs of damage, and testing its operation. Sixthly, suppose a motor is replaced with a new model that has a higher horsepower rating. In this case, the disconnecting means may need to be upgraded to accommodate the new motor's current requirements. Seventhly, imagine a situation where a facility undergoes a renovation or expansion. The electrical system must be re-evaluated to ensure that all motors have disconnecting means that comply with the NEC. Eighthly, consider a situation where a worker is injured while working on a motor circuit due to the absence of a proper disconnecting means. The facility could face significant fines and legal liabilities as a result of this negligence. Ninthly, suppose a facility implements a comprehensive safety program that includes regular training on electrical safety and the proper use of motor disconnects. This proactive approach can help prevent accidents and injuries and ensure compliance with the NEC. Tenthly, imagine a situation where a facility receives a visit from an electrical inspector. The inspector will carefully examine all motor disconnect installations to ensure compliance with the NEC. Any violations found must be corrected promptly to avoid penalties. In conclusion, the NEC requirements for motor disconnects have significant practical implications for a wide range of industries and applications. By adhering to these requirements, facilities can create a safer work environment, prevent accidents and injuries, and ensure compliance with electrical codes.